Hello everyone, welcome to the machine learning course. Please get ready. We are about to officially start our class, and I hope you all can gain something. Welcome back to our machine learning class. Let's continue our learning about DBSCAN algorithm. In this course, we'll guide you to learn the implementation of DBSCAN, and I will give you an instance to have a better understanding of the DBSCAN algorithm. So, how should we implement the DBSCAN algorithm?
Here we provide a rough implementation approach.
For all points in the cluster,
Their kth nearest neighbor is approximately
at the same distance.
the kth nearest neighbor of the noise point is the farther away.
Therefore, attempt to select each point based on the distance between itself
and its kth nearest neighbor, based on the concept of the DBSCAN algorithm
that we learned in the previous lesson.
A question arises: how should we choose the values for EPS and min PTS? To choose the EPS and the min PTS in DBSCAN,
we should understand the data distribution, visualizing the results using evaluation metrics, and interactively experiment to balance cluster qualities and dataset characteristics. DBSCAN is advantageous due to its ability to handle clusters of various shapes and size, while being noise resistant, based on its density definition. However, it faces challenges when there are significant changes in cluster densities, and when applied to high-dimensional data, where defining densities become problematic.
we can directly call the DBSCAN method which implemented in Sclieren library.
And here's the main parameters which should be focused on in the DBSCAN function. The first parameter is EPS. It specifies the neighborhood radius, which default value is 0.5.
The min samples parameter sets the minimum
numbers of points required to form a dense region, and the default value is 5. The metric parameters define the method for measuring distance between points. The default is
Euclidean distance,
and the algorithm parameters relate to the nearest neighbors. Search algorithms employed. Here I show you in an example demonstrate the usage of DBSCAN for clustering data with rings and bulbs
using Python's Sclieren library.
This code generates two datasets, one with concentric circles and other with a bomb, and then combines them. The DBSCAN algorithm is applied to the cluster, the combined data, and the resulting clusters are visualized using scattered plotting. The EPS parameters determine the neighborhood radius,
and min sample
sets the minimum number of points in the neighborhood to form the dense region.
and the Y
The variable hold the cluster labels
assigned by DBSCAN.
I hope everyone has gained some understanding of how to use
DBSCAN algorithms in Sclieren.
We will see you again in the next class.